All right, let's see here. Use an area to evaluate the integral from a to a squared of 3x dx. The key to this problem is that a is greater than 1. Okay, think about what happens if a is greater than 1. The integral from a to a squared of 3x dx. If a is greater than 1, what does that imply about a squared? It will be bigger than a. But if a is, let's say, less, okay, if a is 1, then a squared would be 1, and therefore the answer would be 0, because it would be from integral from 1 to 1. If a was less than 1, then a squared would be greater than. It's an interesting dynamic here. Let's say a is between 0 and 1. Then a squared would be less than a, right? So then you'd get something else, right? Maybe a negative answer to whatever the area is. What if a was between 0 and negative 1?
Well, then a
A squared would automatically be bigger because it's going to be positive, right? So anything less than 0, a squared would be bigger. But it does say a is greater than 1, so a could be here, and because a is greater than 1, a squared has to be bigger than it. So something like this, and we have a line with a y-intercept of 0 and a slope of 3x. So we're looking for the integral from a to a squared, so we're looking for this area here, right? Making a trapezoid. So that would be equal to, the area of the trapezoid is 1/2 of, what's b1? Let's do this. b1 is this height, right? And I take a and I plug it in, so I get 3a. And b2 would be what? Plugging in a squared, so you get 3a squared. So that's 3a plus 3a squared. And then what's the height? The height is this distance, so it'd be a squared minus a. And then from there you could simplify it, but I mean I don't know if you need to so much. You could FOIL it, distribute it, and all. Okay, so we can leave it like that. Okay, but it said use area, so that would imply graphically. If you were going to do it analytically, what do you have to do it analytically? Take the antiderivative. So what's the antiderivative of 3x? 3/2 x squared evaluated from a to a squared. So that's going to be 3/2 of a squared squared minus 3/2 of a squared. So that simplifies to 3/2 of a to the 4th minus 3/2 a squared. So you have to ask yourself, is this equivalent to this? Well, in this case, I can factor out a 3. So it would be 3/2 times, actually, we could pull out a squared, because we can take an a here and an a here. So this would be 3/2 a squared times what here? A plus 1 times a minus 1. And this is a difference of squares that makes what? Yes. Because you can't factor over multiplication. So you can factor out an a of this, and you can factor out an a from this. So that's a squared. So this can simplify to 3 over 2a squared times a squared minus 1, right? So 3/2 a to the 4th minus 3/2 a squared, same thing. Okay? So that's that. If you got it like this, you're fine. Number 2. This one is probably going to get some of you. Maybe all of you, who knows? Who says option 1 is a true statement? Does it make sense to be true? Maybe? Nothing makes sense? What about number 2? Integral from a to b of f of x plus g of x dx equals 4. Is that true? That one's pretty basic, right? It's one of the integral rules. F plus g, the integral of f plus g is the same as the integral of f plus the integral of g, right? Over the same domain. And that's what we have here. 5 plus negative 1 is 4. So 2 is true. What about 3? Can you multiply the integrals? No. So 3 is wrong. The question is 1 right? Intuitively, you would look at it and go, yeah, that's right. Because I see the integral of f is 5 and the integral of g is -1, so f is greater than -1. Or f is greater than g. But what is the integral from a to b imply about f? What does this mean? It's a positive area, but does that mean the curve is always above the x-axis? No. So I could have a graph, let's say f is something that looks like this, just theoretically, from, let's say this is A here, and this is B, and the blue graph is F, and then G maybe looks like this. You get what I'm saying? Now watch, I'm just going to throw some numbers out there. If F is 6 here, that's the area from A to whatever that is, and -1, that would give you an integral from A to B of 5, right? Okay. Let's say this is, I don't know, 1/2, that area. What would this have to be? -1.5 for G to give an integral of -1, right? So that would work. The integral from f from A to B is 5. The integral from A to B of G is -1. So does that imply that f is greater than G for all x values between those domains? No. From here to here, you can see that f is below it. Now, there's just one case, but this does prove that that statement is a false statement, right? So the answer is only 2. But that's the kind of problem that gets you.